Thanks, Andy. I had already forgotten, and we will have a PDF of this available to post to our website later in the week.
All right, good morning, everybody. Thank you very much for having me. As Tarika said, my name is Jeremy Souza, fire protection engineer with Code Red. As far as my interaction with the architecture world is minimal, surprisingly, for a code consulting company. I'm more on the CA services side, Nfpa 241, construction fire safety, phased occupancy planning, impairment planning, fire stopping inspections with a fair amount of fire alarm and fire protection design work thrown in to keep things interesting. So with that, though, I do get dragged in to a number of meetings, more of a, hey, I need you right now sort of thing, with fire department access. As Tarika said, I've spent now 27 years in the fire service. 12 of those years were in charge of fire prevention in my department. So I've been on both sides of the table with this fire department access question, both receiving offers and ideas as to what designers would like to do and what they think will work, and from the other side of saying, you know, hey, fire department, hey, I think this will work for you. So with that, so we'll talk a little bit about the scoping language, where that comes from, access roads themselves, building access, and then the weird stuff that gets thrown in with this fire department access. We would like to say that it's very cut and dry, and it really is. It can be extraordinarily difficult in some cases, and really you're at the mercy of the local fire department with a lot of this stuff. Because of that, why is a big deal. We can do the what all day, reading the fire code, reading the building code, but the why is what's important here. We're going to talk an awful lot about the why, because the why is what gets us what we as the designers want. The AHJ is going to be looking at this with a certain perspective of how do I get my trucks and my firefighters to this building. Operationally, how is this going to work with how this particular fire department is set up? That's the why. And if we can fix the why, we can probably get what we're looking for with the building. So scoping language, 527 CMR, Massachusetts Fire Safety Code, is where we're going for. While we reference NFPA 1 and use that as our base volume for the fire code, every single time it seems that the state amends 527 CMR, they change the base code requirements for fire department access. We have a lot of very unique items in our fire code. In fact, they're different from anywhere else in New England in some cases. Section 18.2 is the fire department access road requirements. Now, beyond that, the fire code flat out says that Massachusetts Chapter 40 overrules anything in 527 CMR, and that's local zoning. So if a municipality chooses to go through its zoning process, they can change all of these fire department access requirements. Roads can get wider, roads can get skinnier. Vertical clearance can get taller or not. Different access things can get thrown in that we're not used to seeing. So while everything we're going to speak to this morning is regarding 527 CMR requirements, keep in mind that that municipality may have changed something in their local zoning, and it would behoove us to take a look at their zoning requirements as we start to dig into what will work for that particular community. So the
Jeremy,
roads themselves, yes.
Sorry, quick question. So that seems really unique to me. Is that really not creating local building codes if you can modify the fire department access on a town-by-town basis?
It's not the building code. The building stays the same, but what goes on around the outside of the building can change. I think that's how they thread that needle.
Interesting. Thank you.
So with the fire department access roads themselves, we have clearances, road surfaces, and then some of the curious geometry stuff that we sometimes struggle with. So what is an access road really? As far as the code compliance, what does the fire code say? It's a road that guarantees I can put a fire engine next to the building. Unobstructed 20 feet, vertical clearance of 13 foot 6 inches. And if I have boulevard roads, which we'll speak to a little bit later, lanes between 10 and 20 feet cannot provide direct access off of those. And again, we'll speak to exactly what that means later. So from the code compliance world, if your road is less than 20 feet, or does not have unobstructed vertical clearance of more than 13'6", it's not a fire department access road. Full stop. That said, in reality, if you can drive on it, it's going to be a fire department access road. If the building is legitimately on fire, the fire department will put a fire engine on your front lawn, or try to drive it through the grass to put it somewhere where they need it to go. The fire code doesn't prescriptively say, yeah, that's okay. So that turns into a little bit of a touchy subject in some cases, that the code says you will give us a road, even though we all know we're going to do off-road driving potentially to try to get where we need to. So this width and height thing, why 20 feet, why 13.5 feet tall? Most fire engines are 8'6" wide. There are some that are a little bit wider than that, plus the mirrors extend a little bit beyond. If you have a ladder truck, they can be up to 13 feet tall. Most of them are just about 12 feet tall, but you can have some that are 13. On tops of fire engines, there is equipment that firefighters have to stand on top of the truck and remove the equipment. They're already 9 to 10 feet up in the air. Now you put a 5.5 to 6 foot tall firefighter on top of the truck, and there's where we're getting 13 feet. The trucks will likely need to be able to pass each other. So as the trucks, if I've got two trucks that are 9 feet wide, a 20 foot wide road is just about enough to get two trucks to pass if they park them right. To be able to squeeze trucks into the scene, sometimes they'll need to be able to park next to each other. And ladder trucks have jacks or outriggers, little arms that come out of the truck to stabilize it before the aerial can be lifted out of the bed. That requires additional width for the truck, sometimes up to 18 or 19 feet, depending on the manufacturer of the truck. I love this picture from Boston. Boston is famous in the fire service for their work with ladders, both truck-mounted ladders and manually carried ground ladders. In this one small building here, relatively small building, there are 5 aerial ladders thrown to that building. It looks as almost they took a shoehorn to squeeze all these fire trucks in, but that's why this fire department access road width becomes a thing, so that fire departments are able to accomplish what's going on in that picture on the right. So the maximum height and width is set by state regulations in every state. All New England states, the maximum width of a vehicle is 18'6". Maximum allowable height is 13'6". Again, those numbers continue to carry across. The ladder truck we have here, it's 11'10" tall, so it meets that requirement. It's 9'9" when you measure from the outside of the mirror to the outside of the mirror. That 8'6" requirement is the actual body of the truck. You're allowed to have mirrors that overhang. I guess the regulations must consider mirrors disposable if they allow over width like that. So if you see a truck traveling down the highway and he has the oversized load signage or chase cars, it's because it's more than 8'6" wide. So looking at this roadway, a typical entrance into a shopping plaza, office plaza, anywhere in Massachusetts. To us, that road, driving a regular passenger car, sure, that road is perfectly fine. And from fire code perspective, it is. If you wondered what a 20-foot wide road looks like, that's it. That road is 20 feet 1 inches from curb to curb. This one, on the other hand, is not. There's a couple of curious things going on with this roadway into this. It's actually a group home. First, the distance between those two, the stone walls on the other opposite side of that driveway is 17.5 feet. The road beyond it is also 17.5 feet wide. So we're narrower than the 20 feet that's required. The other aspect of this road is the geometry. If you look at the road that we're standing on, which is the main road, the public road, so to speak, any fire apparatus that come into this property are going to be coming from the right-hand side and making a right-hand turn to get into that property. That's not a 90-degree turn off the road. It's a 120-degree turn off the road. So as the fire engines come through that curve, they're kind of coming through that 20-foot wide or that 17.5-foot wide gap at an angle. So that's the other reason that this strange 20-foot requirement is a thing, is that we might not be bringing a truck through straight. The trucks might have to go sideways or diagonally through it. And an even worse case scenario, we have a road that's 9 feet wide. we have trees that are overhanging, and just to make it extremely interesting, a gate with bollards to further complicate access into the site. All of these were locally approved by the fire department. Some of them, there are historic issues. This particular facility that we're looking at here dates back to the 1850s. It was a farm and it's in a historical district. So really, you can kind of start getting into fights as to who has the authority to require these wider roadways. And in this case, the fire department conceded that yes, the historical character and the nature of the community overruled the fire department access needs. Fire departments generally try to get equipment that works with their community. This is a news article from 2019. This is Andover, Massachusetts. They have a railroad bridge that's in Andover. They know that the bridge is only 11'6" tall, so they purchased their fire apparatus to ensure that they can get underneath that bridge. The truck they purchased came from the manufacturer. It was 2 inches too tall. They sent the truck back to the manufacturer and had it shortened to be able to make it under this bridge. That said, that doesn't always work. This picture is from November 4th, so 2.5 weeks ago now, in another town in northern Massachusetts. I'm not going to say which one because I have friends with this fire department. They tried to drive an 11-foot, 10-inch tall ladder truck underneath a 10-foot tall MBTA commuter rail bridge. And as usual, the bridge was victorious, the ladder truck was not. If you look at the top of that ladder, the actual ladder itself on top of the truck, it's crushed to the center of the truck. I cannot imagine what was going through the mind of the driver of that truck when he hit that bridge. But this is part of why we stress that 13'6" vertical clearance. This is taken from the driver's seat of a fire engine. This is a roadway to a place of assembly. We would usually think of a place of assembly as having a much higher threshold and tolerance level or a lower tolerance for narrow roadways. This is a place of assembly at a Girl Scout camp that's about a half a mile into the woods. And again, this was built in the 1950s. It was existing before any of our codes would have impacted it. Nothing has changed with the facility since the 1950s, except for their fire alarm system, I suppose. But this is the roadway that we have to use to get to it. It is far 13'6" vertical clearance and far from 20 feet wide. But again, it's existing. It's something that's tolerated by that community. So planning out these roads, as we see the roads start to get drafted during SD and DD phases of the project, and this is one that came across us for a plan review, that yes, they indicate the road is 20 feet wide. And my cursor, of course, is not going to show up because of the way I have the screen set up. If you look up to just slightly up and to the right of the purple cloud that's there, it says that yes, the road is 20 feet wide. But as we dig a little bit deeper, the road is actually only 12 feet wide because 8 feet of it is reserved for parking. So yes, we have 20 feet of pavement, but it's not 20 feet of clear and usable pavement, which is problematic. Additionally, the project team wants or was looking to plant trees around the edge of the road, which trees are great. I spend many of my free hours in the woods, so I'm perfectly happy with trees. That said, trees and fire trucks do not necessarily mix. As the trees overhang the road, now you reduce that vertical clearance. And at some point, 20 to 30 years from now, sure, the trees might be over the road and be able to be pruned back. But for some period of time, that's probably not going to work out. So you can see with this particular drawing for this subdivision or this development that's going in, they're showing the road is 24 feet wide. Excellent. That's what we like to see. The wider the roadway is, the better in most circumstances, at least from the fire department perspective. We talked about boulevards briefly. If you're not familiar with what a boulevard road is, this is a picture of one. So you've got two lanes in opposite directions, separated by some sort of a median or an esplanade. Excuse me. The requirement with Boulevard Roads is that the road itself, nothing can come off of it. So really, this roadway just becomes a conduit to get to the end of that roadway. As you can see in this case, there's houses that are coming off, driveways of houses that are entering this boulevard. As far as the fire code is concerned, that's no longer permissible. You're not allowed to have anything that comes off of a boulevard road. Local zoning, however, said that this is okay for this particular neighborhood. Excuse me for a second. There we go. All right. Gates. You are allowed in certain circumstances to have gates across roadways with fire department approval. And the approval of the AHJ is always, again, a very squirrely and wiggly thing. If you are anticipating a gate for the project, please make sure it is a UL listed gate. UL 325 is meant for vehicle roadways, and it includes automatic openers for emergency vehicles. Usually those automatic openers are it's a microphone that's listening for a certain type of siren that most emergency vehicles have. So you can set the siren to this yelp mode. The gate hears it and opens up automatically. Some gates will have essentially it's a garage door opener. And the intent is that the owner of the building or the owner of the property will give that garage door opener to the local fire department and say, here you go, now you can get through my gate. The downside of that is at some point you have too many gates and you have 30 or 40 garage door openers hanging across the roof of your fire truck, trying to remember which one it is that opens this door. So most fire departments are hesitant to go the garage door opener route. So that's it for the road itself, the vertical height and the width. Let's talk a little bit about the surface for the road. It's got to be strong enough to support a fire truck. Well, what exactly does that mean? So the imposed loads of fire engines, an engine or a rescue can weigh up to 54,000 pounds. Usually that 54,000 pounds is spread across 6 tires, in some cases 10 tires. Ladder trucks and tankers can weigh up to 80,000 pounds, spread across usually 10 tires, in some cases only 6 for smaller trucks. For aerial ladders, when they put those jacks out, the ground pressure underneath those jacks can be up to 75 psi, which is quite a substantial loading. We'll often see in designs, and this comes from the civil engineering folks, this H20 requirement, or HS20, HS20 being a semi-trailer. There is a newer standard for H25, which is a little bit stronger, but I haven't seen H25 come across any drawings that I've reviewed in the past 6 or 7 years, I guess. This H20 requirement is a 32,000 pound axle, so you can have up to 8,000 pounds per wheel because you get you can have up to 4 wheels per axle. That said, the front axle is only 2 tires, so that's only 16,000 pounds. Really, to make sure the civil engineer knows what's going on with this when they're designing your roadways. And for our perspective, on quick plan reviews, if you see a sectional drawing of a roadway and you see less than 8 inches of gravel underneath the road, start asking questions. If you're less than 8 inches of gravel, something weird is going on. That we probably need to make sure everybody knows what's going on. The maximum weights that we usually see for fire engines. So we have commercial fire engines, commercial engine. So the front of it looks like an 18-wheeler truck, or the tractor of an 18-wheeler. Custom engine is usually the flat front of a fire engine. Tankers, which carry a lot of water. Then we have ladder trucks, just a regular straight ladder truck or a tractor drawn aerial, the kind with the person who steers in the back of the truck, the end of the trailer. You can see the weights that we've got here on the steering axle. Obviously, it's the front wheel, and then if you've got a single rear axle or 2 rear axles, how much weight we're putting on. Those ones are overweight. So for those H20 requirements, we are, before anything bad happens, we are already claiming, yep, we overload your bridge or your roadway. So this is something that the engineer needs to be aware of. The tanker weights can exceed the 40-ton weight limit. If they weren't fire engines, you would not legally be able to drive them on a public road without a permit. And that 8,000 pound per wheel H20 rating. The front wheels on almost any fire engine exceed that. As a quick, this is just one screenshot from one drawing that came across my desk for a culvert pipe. And the design parameters, live load HS20-44. So that's that H20, the S for semi-truck. So there's an extra axle thrown in. And the -44 means it was the 1944 edition of that standard, which is still the one that's in use today. When it all goes wrong, this is what happens. This is Chicago Fire Department. They were driving across a parking garage or an elevated parking structure, and the parking structure gave way. Which again, that's a bit of a surprise. This was a washout of a road. This is Los Angeles, California. And again, not necessarily, this is more of a road maintenance issue as opposed to a design issue, but again, still a roadway weight bearing capacity problem. So we spoke a little bit earlier, we've mentioned briefly about aerial ladders and those jacks. So these are the jacks on this particular model of ladder truck. They come out about 2 feet, come down to the ground, and they will lift the entire truck off the ground. So in this case, this ladder truck weighs 66,000 pounds. That 66,000 pounds is going to be distributed across 4 square feet as this truck is lifted up. And the weight is going to shift around as the aerial moves. As we rotate the ladder off to one side or the other, you'll shift the weight of the truck from one jack to another. Realistically, the NFPA standard, NFPA 1901 standard for how to build fire engines, says you can have up to 75 PSI ground loading. That said, I can take an 80,000 pound tower ladder, put the jacks down, and manage to get the truck to balance on 2 jacks. Eventually, it's going to settle onto at least 3. You should have it across all 4, evenly distributed, but again, sometimes weird stuff happens. Realistically, you can have up to 278 PSI underneath those jacks, which is an awful lot of weight for the pavement to be bearing. And this is what happens when the pavement is, or the ground surface is incapable of supporting that ladder. So you can see they've rotated the aerial off 90 degrees off the side of the truck. So all the weight is on that one single outrigger. And in this case, the wet grass gave way and the truck tipped. Road surface itself is usually asphalt or concrete, just like almost any road we see anywhere. In a lot of communities, particularly the rural communities, gravel might be acceptable. And again, that's totally up to the locality where you are. Geogrids, which we've seen underneath gravel, has a maximum of 200 tons per square meter, which comes out to 284 PSI. That's a pretty strong surface to be able to operate a fire engine on. One thing we've started to see recently is permeable pavers. And that's what we've got here on the right-hand side is permeable pavers. Any permeable pavers require the approval of the fire department and need to be marked with approved markings if you can't tell the difference between the permeable pavers and the road surface. So if these permeable pavers were filled with gravel to allow water to filter through them, but it still looked like a road, that's usually okay. It's when permeable pavers are covered with grass, such as this. We've also had some projects recently where the design team has opted, they wanted to use essentially a grass roadway using permeable pavers, but make the roadway completely blend into the grass. From an aesthetic standpoint, sure, it looks great. From a maintainability standpoint, the first time it snows out, a snowplow is going to take all that grass and roll it up in a big muddy mess. So from that perspective, I would hesitate to want to push that. From the fire department's perspective, where's the road? If I look at the front of the building and all I see is grass, where am I going to be able to safely operate a fire department vehicle without it sinking into the grass? As we said, gravel is sometimes an okay surface. In this community, this is a very rural farming community. Gravel's how they do it. Clamshells, if you're down in the southeastern part of the state, also a very, very common material. It's compacted, well maintained. It's probably going to be okay. If you wanted to do this in downtown Boston or Cambridge, I don't think it would fly. If the expectation is just we're going to leave a dirt road, you're probably going to get a lot of resistance, and eventually you're going to lose. Dirt roads do not stand up well, particularly when we get into April and May here in New England, or as they call it up in the northern part of New England, mud season. Eventually a vehicle is going to get buried. And obviously, if this fire truck is on its way to a call, it's not going to make it there if this happens. So that's the road itself and the surface. Let's talk a little bit about the geometry of the road. So with the dead ends, so one of the things we'll see is dead ends for roads. Fire code does 150 feet for a dead end. And a dead end for a road is calculated the exact same way as a dead end is calculated for egress. Go to where you last had two choices and extend it into the end of whatever that corridor, or in this case, that roadway is. Turnarounds at the end of a dead end can be a looped roadway or a cul-de-sac, perfectly fine. A T or an L or a hammerhead, somewhere where a fire engine has to back up, that needs to have special approval from the fire department. Once you hit a turnaround, that dead end distance gets reset. We'll talk about that in a minute. The approval of fire departments, there's very, very wide-ranging tolerances for what a fire department will accept for turnarounds. I know of some fire departments that if you gave them a 300 or 400 foot long dead end, they'd be perfectly fine. Absolutely, well, our guys will back the truck up, not a problem. I know others that at 151 feet, you will give us not just a T or an L to back the truck up, you will put a cul-de-sac at the end of the road, because that department does not want their drivers backing trucks up. Entirely up to the department. And again, it's that approved word. Once we throw in the fire code, something has to be approved by the AHJ. Now the sky is the limit for whatever they want to demand. And that makes it very difficult for us to predict what's happening. So for this dead end, for this facility, we would say that has a 290 foot dead end, but there is no dead end there, as there's a turnaround at the end. So in this case, there really isn't a dead end here. The fire engine can drive through and stay in a forward direction the entire time. Go into that loop, drive through it, and pull back out. This facility, on the other hand, has two legit dead ends. The one, the purple cloud down the bottom, 128.5 feet. The one up at the top, 130 feet. Both of those need somewhere that the fire engine can turn around in. And if you look at the top one, this is part of the mitigation for this project that we'll speak about in one of our case studies later. There's a little extension to the parking lot that allows a place for a fire engine to back into. And that was how that turnaround, or how that dead end was permitted. If it wasn't, then that dead end ends up being about 500 feet long, because it goes from where the first split is down in that lower cloud. So grade, how is our road pitched? Grade cannot exceed 10% unless approved in writing by the AHJ. This isn't, oh, we had a meeting with the fire department and they said it's okay. You need a letter from the fire department that says grade can be more than 10% if you have that on your project. Angles of approach and departure cannot exceed 1 in 20, or is established by the AHJ. And we'll speak to why that can be such a big deal. And grade means a couple of different things. We have grade along the axis of the road, so driving up a hill or down a hill. That's fair. When we think of grade, that's usually what comes to mind. We also have cross grade. If the road is banked or pitched, or if you have a parking lot that's on a slope, both of those can be extraordinarily dangerous for fire apparatus. And if you really are grading any paved areas up next to the building, you're probably going to get a question. And I don't say grade like, you know, we had to pitch the parking lot a 1/4 inch per foot so water doesn't accumulate in the building. This is more to a, wow, I think I might need stairs here because it's such a steep pitch. Very sudden grade changes are also an issue. So those grade changes, this is the angle of approach that we were speaking to, that whole, 10% and 1 in 20 number. The angle of approach is as a fire engine drives up to a sharp hill, or any vehicle drives up to a sharp hill, how steep of a transition can it hit before it takes something off of the truck? Front tires are usually pretty close to the front of the vehicle, but in this case, you can see there's the bumper and that step, that low angle of approach. So if we go to drive up a hill that is sharp, has a sharper turn or sharper grade change than that, the red lines that we see, the truck's going to get damaged and or stuck trying to drive up that hill. Same thing on the back of the truck. We have that same, and this is the angle of departure for the back of the truck. So as they go to drive up a hill, the front wheels, when they hit the hill, the front wheels lift the front of the truck up, the back end of the truck pitches down. And if that hill is too steep or too sharp, the back of the truck can get hung up at the bottom of the hill and either crush the back of the truck or lift the rear tires up off the ground and the truck stops moving. That number for the design standard for how to build a fire engine can be as low as 8 degrees. So when we said, yeah, 1 in 20 is the number, 8 degrees is less than that. So if the local fire department has a vehicle that has that 8-degree angle of approach and departure, they can then go a little bit further and say, no, 1 in 20 isn't what we need. We need a little bit more for that, or a little bit less. So as a visual of that angle of attack, we have our little hill. As our fire engine approaches and drives into the hill, if the hill is too sharp, the front bumper of the truck will smash into the hill, and the truck now is disabled. So this is an example. I don't know the full background of this little hill, but there it is, the Longwood neighborhood of Boston. This is extremely steep, and the top of that hill it's legitimately a sharp edge. You go up this hill, and it immediately transitions. It's like walking upstairs, just it's a ramp without stairs. I personally could not imagine driving a fire engine up this hill, but I see shuttle buses driving up it all the time. And if you look at the sign that's on that post, it says no delivery vehicles on this hill. They will get stuck trying to go up this. Cross grade, fire engines are surprisingly top heavy. So if we park a fire engine on a side slope or try to drive it across the side slope, once the center of gravity of the truck travels outside of the downhill tire, the truck will roll over. So if we make that hill just a little bit steeper, the truck's going to roll over on its side. Fire engines are supposed to be good for 26.5 degrees on the side slope. That's in a controlled condition at the factory. They'll put the truck on a tilt table, lift the truck up. It has to go to 26.5 degrees before it falls over. In the real world, equipment gets mounted a little bit higher in the truck. Water tanks get filled to different amounts. You know, there's a number of variations that can happen. The truck pulls in a little bit faster. The driver turns the steering wheel at the wrong time. That angle changes in the truck and roll over. This parking lot is 19.5 degrees, at least according to my the level that I put on it. I have personally parked a fire engine on that side slope. One of the scariest things I've ever done with a fire truck. I thought the truck was going to fall over, and that was with an engine. If it had been with a ladder truck, it probably would have fallen over. Turning radius. This is a big question that comes up very often, and we often help design teams try to work through this. So the minimum inner turning radius for 527 CMR is 25 feet. It can be bigger than that. You can have a wider radius if the fire department determines that their trucks can't make that turn. And there are fire engines that is true for. The outside of that turning radius has to be at least 45 feet. That doesn't prescriptively say it in 527 CMR, but it does say your road has to be 20 feet wide. So if we take the 25-foot inner radius, add 20 feet to it for the roadway width, now we have a 45-foot outer minimum turning radius. 527 CMR does require a swept path analysis. We'll show you what those look like in a minute. Does that 25-foot inner radius mean the design team can't say, well, we want to put a 10-foot radius for this roadway? Because fire code says 25, so we can't do 10. But that's not true. You can do 10. You can do 0. You can have sharp corners if you'd like. But the roadway has to be able to accommodate that 25-foot radius. If you visually to see a 25-foot radius, that's what they look like. Not that you're standing in the rear parking lot of Code Red's office in Southborough, but If you wanted to go in the rear parking lot, that's a 25-foot radius. That is a 1-foot radius. Is that allowed? It depends. You know, can a fire engine make the turn? I looked at this turn and said, no, I could not make that off of that roadway. So the turning radius, why 25 feet and why 45 feet to the outside? So when a vehicle turns, it pivots on, in this case, the middle of the rear tire. If you're ever trying to drive your car in a parking garage or around a bollard or something, as you back up or pulling forward, as long as your back tire on the inside of the turn passes that object, turn the wheel as sharp as you want, you're not going to hit it. Your vehicle is going to pivot away from it all the time. So in this case, this fire engine is going to make a left-hand turn. It's going to pivot on that tire. So we'll come tearing around the corner. We have the track that the tires took. So you can see the tires, the part of the truck gets a little bit wider. As the wheels come around, they don't track together. The rear tires track inside the radius while the front tires stay on the outside of that turning radius. But fire engines also have overhangs. The front of the truck overhangs 3 or 4 feet. The back of the truck can hang over as much as 18 feet for some fire engines. So that turning radius ends up even wider because the body of the truck is outside of the tires. So that swept path analysis is done with a computer program that many civil engineers have that takes the characteristics of the truck and mathematically models where the body of the truck and the tires will go. And that'll give you this, these sorts of graphic representations of what the truck will cover as it's trying to take a turn. This can be applied to a plot plan of a proposed development or building, and they can mathematically drive a fire engine around and make sure it'll fit. So you can see, particularly with that center image there, that the body of the truck scores a much wider radius than just the tires will do. So to measure it on your own drawings, we use what we in our office have. I is 20 years in the fire service. I like donuts. So here it is. This is the donut. The blue area of the donut here is where a fire engine can drive. So that's a 25-foot inside radius and a 45-foot outside radius. And if you look at the drawing that we're on, the radius of that curve is only 15 feet. So how is it we need a 25-foot inner radius, but we have a 15-foot inner radius here? How is this going to work? Really, it's just the donut area that we're concerned about. As long as the fire engine can stay in the donut as it drives through, it's fine. You can have whatever inside radius you'd like. So that path here is where the fire engine would actually drive. We lead into the donut is the curve, and then we exit that donut and continue on the straightaway. As long as that's not on top of the curb, it's a win. So in this case, even though it's a 15-foot inner radius, because the roadway is 24 feet wide, it gives extra room for that donut to fit. This is a different project. This is where the road actually is intended to be. So we don't know which direction fire engines are going to come into a site. So we need to accommodate from the main road here, both left and right. The redded out areas are the grass areas where the donut is exceeded, if that makes sense. So that turning radius, anywhere that's red, would need to be paved if this is the configuration of the road they wanted to use. This was another project, had nothing to do with fire department access. This was partially a design project for us. This neighborhood, if you see down the bottom, Washington Street, this road snakes up a hill. And you see the light gray contour lines. I took a look as I was looking at this drawing for entirely other purposes, I noticed this, what looked to me like a pretty sharp curve going into the rest of the site. And it was back up in here. Measured it, it's only 20 feet for the inside radius. Okay, do we have a potential fire department access problem here? So we put the donut on it, and it turns out that no, we don't, because the roadway was wide enough. It met that 25-foot inner radius and the 45-foot outer radius. So moving on to other things we find in the roads, traffic calming devices are now becoming extraordinarily popular in many locales. Speed bumps we've been familiar with in parking lots for past 50 years. Speed humps or speed pillows that we're now starting to see. The purpose of these is that gap that's between the pillows is the tire of a fire engine. So in theory, a passenger car is narrow enough that you would have to slow down to hit these, but a fire engine's tire track fits perfectly in those grooves and they don't have to slow down. I can tell you that the pickup truck that I drive apparently has the same radius, same width, because I can drive through that without having to slow down even. Speed tables, usually popular for crosswalks. S-curves or chicanes. I haven't seen any of these in New England yet. I figure it's only a matter of time, but I would be very surprised if a fire department allowed this configuration of a road. And roundabouts are becoming very popular here in southeastern New England. Whatever traffic calming device you put in, make sure that the fire department knows about it and that they're okay with it. From the perspective of driving a fire engine, this is what it looks like going over one. This truck has to slow down to 7 miles an hour to go over that hump. There was a study done out of Portland, Oregon a few years ago that reported for different types of traffic calming devices, you can lose anywhere from 9 to 40 seconds of response time by having to go over each different traffic calming device. So being installed on main roads can have a substantial impact on response time for the fire department. 527 CMR does reference curb cuts. That curb cuts have to be 2 feet wider than the road on each side of the road than the road itself. So in this case, the entrance to this parking lot, the curb cut, if we come straight out, the curb cut is supposed to be 2 feet outside of those 2 lines, and it's not. So the green one is 2 feet, the red one is not. And this got a picture that I had to use this parking lot several times and kept driving over the curb. So that's why it ended up in the presentation. To mitigate curb cut issues, and you can also use these in roundabouts, or really anywhere where you have a potential turning radius problem. With the AHJ's approval, you can propose changes to the curb. So if we do a Cape Cod berm, these are very easily driven over. Yes, it may make a mess of the grass, but if it's just 6, 12, 18 inches that you need, this might buy you what you're looking for. Having no curb there, but putting brick pavers to show where the edge of the road is. You see this very, very frequently with roundabouts, that the inside of the roundabout to drive 18-wheelers through it, that tractor trailers can't make that full radius. So they'll do brick pavers with the knowledge and intent that a tractor trailer can almost drive straight through rather than having to follow the lines all the way around. Or chamfered curbing. Use regular curbing, but instead of a sharp 90 on it, put a bevel on the side of it. Whatever you're using for the road, it has to be maintained. If you start developing potholes, or in this case, potholes that would eat vehicles, that's going to have to be addressed by the owner. This is a fire department access road leading to a shopping center. That the road has not been well maintained, and this is a very, very difficult place to try to navigate any vehicle, let alone a fire engine. Fire lanes. Fire code does discuss fire lanes. Fire lanes are at the sole discretion of the local AHJ. So the head of the fire department is who's responsible for designating fire lanes. It is not prescriptively required by the fire code. It's something that the local jurisdiction has the authority to say, we want one here and we want signs, or whatever you have is fine already. So any questions so far?
Jeremy, honestly, the chat is still quiet. I hate to say it because I like giving you guys lots of questions, but I think you're just doing a very thorough job.
Jeremy, I do have one question.
Please, Greg, go ahead.
This is a problem I see not on private property so much as in rights of way over railroad tracks. And I'm thinking of one in Stoneham. They've reworked it several times, I look at it and I wonder, how does a truck, particularly a fire truck, navigate that? So in the course of these things being developed, do municipalities typically engage with the fire services or whoever is responsible for those rights of way? Is that the MBTA? How does that work?
So you use a 4-letter word in there, MBTA. MBTA is unique in that they're kind of the, no, it's ours and everybody will leave us alone and we'll do what we want. Yes, the local fire department on state property has some sort of impact there, but MBTA very often does what they want to do. So other railroads, you end up, there's federal requirements for what railroads are required to do and what they're permitted to do. So you run into that as well. There's some very, very weird jurisdictional overlays when we start talking about trains.
Jeremy, we have 2 additional questions coming up. First is Wendy Pescol. She has a few questions, but she didn't post them. So Wendy, would you please, Wandy, would you please unmute yourself so you can present them?
Hi, and thank you. Please let me know if you can hear me.
We can. You're good.
It is so wonderful to hear about this. I feel like a few of us have been talking about fire access for a minute now. So I work on additional dwelling units, particularly in the city of Boston, but I've also been following how other municipalities have been going at this. And so I have 2 sets of questions. And again, thank you, Jeremy, for the incredibly thoughtful presentation that you put together. The first is around fire access, right? Some of our roads aren't necessarily 20 feet wide. And so I've been thinking a lot about what the potential alternatives could be, right? If we ask folks to sprinkle their ADUs or to even think about other fire protection sort of methods, what are some of the ways that you've seen other municipalities really mitigate around that when you don't have the 20-foot sort of like driveway as an opportunity for a lot of homes that already exist?
So when you say the roadway, are we talking a public road or are we talking a driveway? So it was, I want to say it's your road, but it's your road versus that municipality's road. So the fire code does prescriptively allow the fire department, the local fire department, the head of the fire department, to require additional fire protection features if you can't meet other fire department access requirements. And it specifically calls out that they are allowed to request hydrants, cisterns, or additional hydrants, cisterns, and or a sprinkler system up to an Nfpa 13 sprinkler system. And we'll talk a little bit later about the 13D, 13R thing. If you're providing a fully sprinklered building and you've got hydrants nearby, you have essentially reached the limit of what the local fire department can require for mitigation. You know, I would say that that should not be the roadway shouldn't be the make or break thing. If you have an 18-foot road and you have a fully sprinklered building at the end of it, one would think that that should be the end of the discussion. We gave you a fully sprinklered building, we're good. I know for a fact that there are fire departments in the state that will lock their heels in and say, no, this is what we're requiring and you will do it. And now you're at loggerheads with the AHJ. And I mean, that's a personality thing. That's not a fire code thing.
Thank you. I really appreciate your sort of transparency and clarity around that too.
Sure.
And then the second question that I had was around the turning radius. You mentioned 25 feet. And again, we've done sort of like turning radius studies for a number of like neighborhoods as well. And it just, emergency vehicles essentially won't make that turn. And so just wondering if there's also been any sort of emergency vehicle innovation that you've seen around where, we're talking about sort of like different sizes of vehicles, that sort of thing, that could essentially still make it to a particular home in the case of an emergency.
So over the past 100 years, fire engines have gotten nothing but bigger and bigger and bigger. Firefighters want to carry more stuff to the incident and more water and more hose, and just the trucks I drive today are far larger than the trucks I started driving 27 years ago. Like I totally get that. That said, in the past probably 15 years, there have been a lot of changes to how a fire truck steers. The wheelbases have gotten shorter in many circumstances, and the front, the steering axle used to be, you could get about 40 degrees of turn. Now they're up to 47 degrees of turn. So yes, fire trucks are able to do more today than they were 20 years ago. But that also depends on the municipality that's purchasing it. When the town says we want to buy the biggest, bestest grand fire engine there is, versus the town that says, hey, we got a lot of really tight streets and we need to buy a short wheelbase truck that can do that. So again, personalities get involved.
Awesome. Thank you so much.
So you're welcome. But I see we have
one more set of questions from Laura. And I'm quoting now. You touched on it quickly, but I'm seeing tabling of streets being introduced and proposed on a number of projects. Block-long elevated roadways with bollards separating driving surface from pedestrian surface. Is this something that's controversial for fire departments?
Absolutely. For those of us who have driven through Cambridge, and this started 5 years ago when the bike lanes appeared and the parked vehicles came 8 feet further into the street. Cambridge Fire Department was extraordinarily upset about that. And it has placed operationally, it has made a lot of negative changes for Cambridge Fire Department on how they do their job. Fire department can't jump over parked cars. Same thing with tables. If they put tables between the bicycle lane and the drive lane, can't really get a fire engine across that either, at least not easily. Part of what Cambridge saw was being able to reach buildings with an aerial. The ladder is generally 100 to 110 feet long. You can't make it any longer. I can make a fire hose as long as I want. Can't make a ladder any longer. So when I park the ladder to the building, I can reach higher. The farther away I park, the lower that ladder can reach. And Cambridge found that they were losing, in some cases, up to 3 stories of reach by sliding the trucks farther out into the street where they could park them. So yes, it is extremely controversial for fire departments to be seeing the pedestrian friendly. It's strange to say we don't like pedestrians, but we don't like pedestrian access. You know, the more places you can drive a fire engine, the easier it is.
Thank you.
You're welcome.
Jeremy, if I might, along the same lines, a couple of years ago, an architect from the western part of the state asked us the question for fire access. So he was doing I think it was a combination. There's 2 buildings on a small lot with a large parking area in the middle. It was for kindergarten on one side or something for kids. And on the other side, it was a retirement facility. Both of them were 1 story. They were asked to widen the access into the property and provide a way for the fire vehicles to get out. So all kinds of parking would be obliterated. And so the architect sent the question to this codes committee and asked what he can do. And as we looked at his site plan, it showed the adjacent roadways, and all of the adjacent roadways, including a very sharp corner. It was probably a 135 degree turn, maybe it was more than that, 180 degrees, not quite. Yeah, it was a very sharp corner. What happened is those existing roads were did not meet any standard. The fire department would have had an impossible time navigating those roads just to get to the property. And those were roads that were not within the owner's purview. So the question was brought up, what can we do so we don't lose all this required parking for the users of the property? This was all nonprofit. So the proposal that members of our group suggested was that they look for compliance alternatives as a point for negotiation. And fortunately, the fire services was open to that. But short of that, I don't see what the owner or developer could have done. So you mentioned one of them, which is additional hydrants, and that seemed to be the winning proposal. How often do you run into this?
That's additional hydrants and some other stuff we'll talk about in a few minutes. That's usually the fix for any fire department access problem. There's only so much real estate to work with, and what's next? Usually it ends up being a couple hydrants, some fire department connections, some standpipe stuff. So with that, we'll keep cranking on. So this is the outside of the building. How close do we have to get the road to the building? And there's two thresholds. The first one is what we call in our office the 50-foot rule. We have to give a fire department access road, so it has to be the 20-foot wide road with 13'6" vertical clearance, 25-foot inside turning radius. That road has to meet all those requirements. We need to bring that road to within 50 feet of a door, not every door, a door from the building that can be opened from the outside and provides access to the interior of the building. I'm sure you've seen, if you look at many Targets or Walmarts, Home Depot, you'll see doors on the outside with no hardware on them. Those doors don't count. Yes, it gives me access to the building, but it has no hardware. I can't open it from the outside. Those doors would not meet that requirement. If you have a building that doesn't have adequate frontage and it's behind an existing building that does. So in my town, we call them a hammerhead lot. We have an easement or a right-of-way that travels through and a building behind another building. Now that road has to be within 25 feet of a door. If you're stacking buildings one behind the other. So that 50-foot rule, here's our, we'll see this in a case study later again, but for our condo building here, there's multiple doors to get in, and because it's a condo, as soon as we say the word condominium, all sorts of weird starts appearing because you've got different owners and is it different buildings and all a bunch of mess that we try to push that to the side and don't let the fire department know. That said, most of the doors in this building are less than 50 feet. I just need one door that gets me into the building. My lowest is 28'5". That's a win. So if you notice where these are being measured from, they are not measured just from pavement. They're measured from where you can park a fire engine. So if you look at the parking spaces on the left and the right, those lines continue out through beyond the parking spaces to the spot where you could physically put a fire engine. So for this building, where's my entrance? What entrance gets me into this building? And there's the pathway. Our door is inside that little front lobby. If that door is within 50 feet of where I can park a fire engine, we have satisfied that requirement. So the other number we have, we got the 50-foot rule, and then what we in our office call the 150-250 rule. Access roads have to be provided so that the entire exterior of the building is within 150 feet of an access road on an approved route around the outside of the building. So firstly, we have the approved word in there. So the AHJ has a lot of flexibility in what they can accept and in what they're allowed to accept and not. And really the whole purpose of this rule is to allow fire hoses to go around the building. That you can run a fire hose from a fire engine and go completely around the building. If the building has an Nfpa 13 sprinkler system, the 150-foot number gets extended to 250. That is a Massachusetts amendment. In the base code, it's 450 feet. If you go to Rhode Island, if you go to New Hampshire, if you go to Maine, it's 450 feet. But in Massachusetts, it's only 250. Fire code specifically calls out it is an Nfpa 13 sprinkler system. It's not a 13D, it's not a 13R. So if you have a 13R system, you're at 150 foot. If you have a 13 system, you're at 250 feet. That's super, super important and critical to some of the workarounds that we're going to talk about in a little bit. But I mean, everybody needs to have that have their mind wrapped around that you have to use a full 13 system to get that exemption. So fire hoses on a fire engine are usually stored just above the pump panel. So immediately behind the cab, there's 2 or 3 racks, if you will, usually called crosslays. The fire hose that's on that is usually 200 to 250 feet long. That's where we get the 150 and 250 foot numbers from, is the length of a fire hose. And that's about the maximum amount of fire hose that a single crew on a fire engine can extend around a building. So that's how the hose comes off. Usually you need about 50 feet to get the hose off the truck. It can be front or back. It doesn't have to be 90 degrees off the truck as they're showing here. But hose comes off the truck and they can extend it and walk it around the building to where it needs to go. So for this building, if we're going to assume that it has a 13 sprinkler system, from the places where we can park a fire engine, we've got to be able to hit all sides of the building within 250 feet. And in this case, you can see the fire department access roads are the orangey color. And the blue lines are marking out the fire hose distance, if you will. When you measure these out, try to mess with your lines to equal them out. So if you look at the bottom numbers here, we've got 210 feet, 215 feet. That kind of, you know, that's the number we're looking for, is where do the two lines meet? If I pull a hose from this side, pull a hose from the other side, how long do they have to be to meet in the middle? But again, the entire outside of the building within 250 feet. This is where we get into a lot of minutia, and things can get really ugly with an AHJ. To do exterior access, it is almost impossible to use a straight line. What we have shown here, they're kind of straight lines. You can see them going down the stairs on the right, but this might not be possible. Do not cross over fences or guardrails. If the firefighters have to jump over a fence or jump over a guardrail, they're not going to. So that's not going to be a legitimate number or a legitimate distance. If you have gates, that might be okay, but it's not a guarantee. Do not cross retaining walls of any height. And this stuff is not in the fire code. This is from being on the receiving side of fire department access, what the firefighters and the fire service is going to be looking at for those numbers. If you have a retaining wall of any height, somebody's going to fall off of it while extending a fire hose. End of discussion. They are not going to accept any sort of retaining walls if you have to go over them.
Jeremy, I'm just curious, on the not crossing fences or guardrails, if the fire department doesn't have any other options, will they consider just basically breaking or damaging the fence or the guardrail that is there to get in? Or will they just say, I can't do anything about it?
In the real world, if there is a fire, they will break through whatever they have to break through. But
Okay.
they're not going to permit you to build a building and say, yeah, go ahead, you can block it off. We'll just worry about breaking stuff later. They're going to request that access be given,
Makes sense.
easy access be given ahead of time.
Thanks.
Avoid steep hills. So what is a steep hill? If you would think you would probably want stairs on it, that would be, I would consider a steep hill. Do not cross through planters. Don't go over benches. Go around rocks or shrubs. Again, that kind of ties in with the planters. Grass might be acceptable, but in New England we have snow, and again, come May and April, April and May we have mud. Fire department, you've got a grassy slope. Fire department's probably not going to accept it. Improved walking paths are usually okay. Question then is, how wide does the path need to be? And the number that I generally give people, if you need a 48-inch exit or 48 inches for your exit width, your pathway should probably be 48 inches. That's probably the best way to look at it. Whatever your required exit width inside is, just continue that outside until you make it to the public way. So your exit discharge just has to be wide enough overall. Might get into stuff about carrying ground ladders. If you get into that, give me a call. We'll work through it. And then what constitutes an improved walkway? Does it have to be concrete or asphalt? Maybe. Is gravel okay? Is stone dust okay? Maybe. Pavers are probably okay. If you're saying it's just grass, that's probably not going to be good enough. So here we have our out the exterior of our building. We have a public road to the left, and obviously the building to the right with a sidewalk that runs down it. This is a guaranteed win every day of the week. We gave you a straight concrete sidewalk. That is exterior access. Absolutely, I will 100% agree with you. But we also know the fire department's going to park a fire truck on that public road, and they're going to want to extend hose lines to come down. Okay, well, what about the hill? Well, it's a grassy hill. Maybe. You know, the fire department might be okay with it, and might not be okay with it. This is that approved thing. Very situationally dependent and personality dependent. We also have some trees, planters, and stone walls that are acting as little retaining walls. These red areas are a no-go. Do not try to use these as the pathway for your exterior access. So when we go to measure it, you'll end up with lines that look like this. So we're going out to the road, starting at the road where we can park a fire engine. So in the parking lot, but not where you're going to see parked cars, and then follow the walking paths. If I did a straight line, I could get better numbers. I agree with that, but a straight line might not be a win for you. If you go to the fire department with this, they'll receive this document and go, oh yeah, you're thinking of our best interest in how to stay on pavement. Absolutely, we agree with you. There are some circumstances though, such as on the bottom of this building here, where you come around off of pavement and you have no other choice but to go through grass to get into this little courtyard. So once we get into that, sure, a straight line across the grass and we'll do what we can. So assuming this building has a 13R sprinkler system, our number is 150 feet. And you see the highest number we have here is 138 feet. So that's a win. That 138-foot number down the bottom there, if I shift its endpoint to the left, it only gets smaller. So that's pretty much the farthest distance I can get. And we try to measure these so that it gives you the worst case scenario, but they even out. So to mitigate that, you can't hit the 150-foot distance. Put in a 13 sprinkler system. Now you just bought an extra 100 feet on one side, but we have two sides to it. So now you bought 200 extra feet of exterior access. If you can't meet the 250-foot distance, first, make sure you really have a 13 sprinkler system. Just to make sure, just satisfy that requirement. One mitigation that we have found that works pretty well is to put a standpipe hose station at all exterior entrances to the building, and put fire department connections that feed that standpipe at places where the fire department's going to want to put a truck. So this is for buildings that don't require standpipes to begin with. So I've got a 2-story or 3-story residential building that's 600 feet long. Fire department, I'm 300 feet for my exterior access. The purpose of that number is so that firefighters can put a hose line into the building and reach around the building. If I can give them standpipe hose valves at the ground floor at the exterior entrance, now they have a place to connect fire hose. And we have found a lot of fire departments are okay with this. It's not prescriptively allowed. It's a compliance alternative. Hey, we think this will work, and they have bought in on it. And if you think the other direction of a high rise, if I've got a building that's 1,000 feet tall and I put standpipes through that building, what's the difference if I take that 1,000-foot building and lay it on its side? Now I'm still 1,000 feet long, and there's just less stairs. So that's one alternative that we have found good success with. Your mileage may vary again, depending on personalities. Some of the other considerations we've run into, bridges, overhangs, traffic, terrain, and elevation changes. Bridges, this site, this island, is or was a place of assembly for 700 or 750 people, for clam bakes and wedding receptions, that sort of thing. There are 2 outdoor covered pavilions, both for about 200 people each. There's a single family house, there's a bathroom building, and there's a kitchen building. The only access into this is a 350-foot long bridge. The bridge was built in the 1950s with a 4-ton rating. This turned into a 15 to 20-year legal battle between the town and the owner of the island. It got very, very contentious. If you look to the left of the trees on the island, there's a bunch of little gray things that look kind of like water tanks. Those are all concrete blocks. As part of the owner trying to get the town to agree to use the bridge, he placed concrete blocks on top of the bridge in an effort to weight test it. Look, it holds up all these concrete blocks. It must be good. And the town said, no, get an engineer to stamp it and we might buy into it. And he couldn't get an engineer who would sign off on a fire engine driving across this 4-ton bridge that was never maintained. So access such as this, that was a big deal. So that's what it looks like today with this gate that's closed off. Bridges do fall down. Obviously, bridges have to be maintained. Fire trucks, we already talked to her about earlier, are overweight for most bridges. So, you know, it is something that does happen. That one's California. I don't know what the resolution was for injuries with that one. This one, that bridge went through, there were, for this particular picture here, there were 6 fire engines on the other side of the bridge that were trapped and couldn't get back over. The bridge failed after the fire trucks had gone over it. Anybody recognize this one? This is not Moon Island. I can't remember it now. Spectacle Island to the left, Moon Island on the bottom, Deer Island. This is home to a hospital for the city of Boston. Down the bottom of the picture, that's the Boston Fire Academy and the Boston Police shooting range. There was a causeway that went out to this island for decades and decades and decades. The Boston Fire Department recognized this island was so far away from anything, they actually built a fire station on the island just to protect it. That said, the bridge over time became a maintenance problem and the city got rid of it. Once they got rid of the bridge, they also got rid of the hospital. So there is no longer, that's all vacant now down on that island. And that's all that's left of it today. Cantilevers and overhangs. Anything with a building over it from a fire service perspective is bad. No firefighter wants to drive his fire engine under any building. That very famous building on the left-hand side, there's no way to get up to the building without driving under the bulge in the middle. So that one, you know, yes, it's a well-built building. It's type 1A building. It's probably not going to fall over. Still, they're not going to really want to park a truck under it. They might walk under it, but they're definitely not parking a truck under it. So when we want to get into that 50, the 50 foot to the entrance number, watch out if you've got overhangs, because that might eat up some of your entrance ability for that 50 foot roll. Cantilevers, porticocheres, they're not driving a fire engine under them. For on foot for your 150, 250 numbers, maybe it's a 50-50 chance whether or not they accept it. This building on the right, that's kind of a covered parking area with a building over it. I personally wouldn't allow that for the 150 or 250 foot access. And this building, it does actually have vehicle access to both sides, but if I was the reviewer for this and I was receiving a plan that said, no, it's okay, you can walk under the building, the answer would be no, I am not approving that walkway. Here we have a country club in Quincy. If anybody's been there, they have great food. From this side of the building, looks just like a club building. That said, if we go walk around the building, it's sitting on the edge of a 50-foot cliff that dumps into an old granite quarry. How on earth did you, and you cannot walk around this building. I tried once. I parked in the wrong spot and had to walk up the hill, and it was miserable. So that said, how did this building get built? How did the fire department sign off on this? It has a full 13 sprinkler system. That's the mitigation. If you can't do these things, the fire department can require up to and including additional hydrants, cisterns, and or a full 13 sprinkler system. It has the full 13 sprinkler system. You've met our list of demands. Go ahead and put your building up. Water. How do we drive a fire engine up to these buildings? Obviously, I hope everybody would know where these are. Can we meet the 250 foot numbers with this? Sure, you can drive a fire engine down the pier. The pier is strong enough to hold up a fire engine. And notice they wrap completely around the building. So I do have full access all the way around. Conveniently for Boston, if you look in the center, Boston also put their fire boats there. So you have some mitigation that you can point to them and say, hey, you put fire trucks that float. Can we get a little bit of leeway since you have that option? They will say no to that, by the way, we've tried. We have this hotel sitting in Mount Hope Bay. I know it looks like a lighthouse, and yes, it does have a flashing light on top of it. in the dark, but this is a single unit hotel. You can rent the hotel out, rent the lighthouse out for the night, take a boat out and have a nice night. How did that get permitted? You know, it sits 3/4 of a mile from the nearest land. How do we provide fire department access? Well, the fire department has a fireboat, and they were okay with this non-combustible building with the features of fire protection that the lighthouse has. But the fire department was accepted it that, yeah, we can get out there and rescue somebody if we need to. So it never hurts to ask, I guess, is really where that comes to. Really, every community has its own tolerance for what they will accept. Bigger cities are usually okay with narrow alleys and tall buildings. They're used to it. They are not okay with long distances to fire hydrants or to fire department connections. They don't want to pull a lot of hose. I pull up to the building, everything I need is right here. There's a hydrant across the street. There's the fire department connection right here. There's the door. Let's go inside. If you get smaller towns, usually they're not okay with alleyways. They want separation between buildings. They want wide roads. And I find more often in small towns than the bigger cities, the requests start to come in for things that are not in fire code, the building code, or mass general laws. We want this thing. Well, you can't ask for that thing. And obviously we all know when you tell the fire department or the building inspector, you can't ask for that. Well, the game is now on and you will pay. Local opposition also ends up coming out in fire department access. So if you have a development that's going in or a project that's going in that is contentious in the community, this may be the mechanism that is used to shut that project down. If you have plans that were previously approved and, oh, we changed our mind, we want this now. The moving of goalposts. Hey, oh, you met this requirement? All right, we'll add this one in. Oh, you met that one too? Okay, here's another one. Or again, for things that are not in the fire code or the building code. We've seen aerial access. We need to be able to put a ladder truck to all sides of the building. So you need to give us a roadway around the building. Collapse zones. We won't park a fire truck within 50 feet of the building in case the 50-foot building falls down on top of the truck. So you need to give us a roadway that's 50 feet back. We want a road that wraps around the entire building. We don't want to have to walk. We've seen those all appear. So case studies. So let's look at some of the real life implications here. So we've got a new residential building. This is it's not assisted living, but it's senior housing, built in the middle of a wetland. This project, there was something along an 8 or 10 year negotiation with this town's conservation commission to get the site plan set in stone. And it is not changing. You want to move this retaining wall? No, it's going to take us another year. This is where the plot plan is staying. Fire apparatus, the turning radius was 0. There were very sharp corners. The fire department access road can't go around all sides of the building because of where the building is and the massing of the building versus the site. They can't push out any farther because then we start filling in more wetlands. And the roadway to get into this site crosses over a bridge. They're going to build a bridge. So at least we have the opportunity to take a new bridge and say, yes, it has to meet these requirements. So here's the building. You see the building on the left-hand side, and you see the wetlands that are surrounding the site. It was almost on like an island in the middle of a swamp. So this roadway that we've got here, what kind of sprinklers do we have in the building? Well, it's a residential building. It's 3 stories tall. We would usually expect to see a 13R system. If it has a 13R system, I do not get my 250-foot allowance. I'm stuck at 150. So we bump the sprinkler system up in the building to a full Nfpa 13 system. The site plan is set in stone. It's not changing. Can we move the parking spaces around? Can we add pavement? Well, the answer was no for adding pavement. So instead, can we use permeable pavers? They allow groundwater infiltration. Does that bias anything? Well, yes, you can put this much permeable pavers and we'll allow that. And then turning radius. Can we move the roads around a little bit? The answer was no. We ended up instead of using full-size curbs, we put Cape Cod curbs in. And now the fire engines can kind of track over the edge, and the ownership was okay, and the fire department both okay with, yeah, you can have your tires go over the grass, and we'll allow that. And make sure the bridge can support fire trucks. So there's what we ended up with, the proposed access road for fire engines. Met our dead end requirements. They were both less than 150 feet and provide adequate backup space. And the fire department was, for this community, was awesome to work with. Everything that we proposed with a, here's how we're going to try to make it work for you, they were totally on board. They were in no way aggressive with us. They really were a pleasure to work with. I will give you one great hint. If you go to the fire department and any of your requests start with the word just, you're going to lose. If you say just do this or just do that, the answer will be no, and you have now created a contentious situation. Try to figure out from the fire department how they do things and kind of skew the conversation towards how we can make our project work with what your normal operational procedures are. So getting around the building, we could get the roads tight enough up to the edge that we hit that we're less than the 250-foot number. In fact, it was 240 feet from both directions. So just came in a hair under, but that's all we needed. Case study number 2. So this is a 40B housing development. I'm sure all of you are familiar with the 40B process. This turned into a very contentious project over time. 18 residential buildings, 8 and 9 unit condos, all 2 stories tall with a walkout basement. The fire department roadways, the road is a giant loop that goes through the facility, and there's little stubs for parking lots. So we had some turning radii questions that came in. The distance numbers are what hit us. The 50-foot rule, what is an exterior entry versus not, and then 150 versus 250, and then some other distances that will that the fire department tried throwing as well. So here's the plot plan for the entire subdivision. Kind of busy. I have some of them I colored in to make it a little easier to look at, but wasn't able to do with the bigger one. So you see the roadway that wraps around, that red line or that doubled up red line, that is a swept path analysis to prove that the largest fire engine for this community could make it through the site. We'll take a little closer look down here. So you can see the swept path analysis does show the fire engine can make it through. So we'll zoom in up there. So here we have those 2 parking lots. The one on the left is a 190-foot dead end. The one on the right has a 240-foot dead end. We need to fix those dead ends. So how do we do that? Because the site, we can't take away buildings. We can't loop the roadway outside beyond. So we need to do something. And the civil engineer for the project came up with these little turnarounds. They're going to use permeable pavers and put grass there. The fire department was okay with that. Now that shortens my dead ends to about 100 feet. And the fire department has to approve that, and they were okay with the approval on that. We saw this already, the 50-foot to the interior access. In this case, we had 50-foot to almost every interior access door in the building, except for that 118-foot one, which is a stairway going up to the 2nd floor. That said, the fire department, we convinced them the number is 50 feet to an exterior door, not all exterior doors. So they kind of rolled over with that. And then there's some other doors that were available. And then the 150 versus 250. A few of the buildings had fairly long distances for exterior access. In this case, it was 192 feet, 191, 192 feet for this one. That's over the 150. The original plan was we were going to put a 13R system in the building. We upgraded the sprinkler systems in 4 of their buildings and got them a 250-foot number instead of 150. So a little bit of expense to increase your sprinkler system, but the offset is now you get to put the building where you want and don't have to pave around it. So that brings us pretty much up to the end. That said, any questions or comments or mean, nasty things from anyone?
All right, well, first and foremost, we need to thank you for a very thorough and detailed presentation. We don't get this topic very often, so this was an awesome thing. All right, before I forget, I did just post to everybody the continuing education link back in the chat box. If you are an AIA member, please just give us your name and your membership number. If you are not an AIA member but would like to get a certificate, give us just your name and your email. That's what the BSA requests of us. I'm perfectly fine if you want to unmic yourself or unmute yourself so that you can ask your questions directly to Jeremy. We'll hang on for a few minutes.
And John, thank you very much for, yes, it's Long Island. It's not Deer Island.
Welcome. I do actually have one question for you, Jeremy.
Sure.
This is just picking up on something Wendy has posed earlier, but I'm hoping maybe we could talk a little bit more about it, which is, the legislature last year passed a big housing reform bill, which, the thought is that somehow it will help spur on construction of the much needed housing need. There's 400,000 units that were short. And one of the items that was in there was without getting into all the details, sort of a loosening of the restrictions that have been in place for a long time around the creation of ADUs in people's, so this is obviously on the residential side, not the commercial side. And so what I'm curious about, there's not a specific detailed question here. It's more of your general thoughts around fire departments in general, the ideas of creating ADUs on existing properties. And, given that what most of these buildings are, they don't have full kitchens in them. At best, they have an operating bathroom, usually a large room, but don't have full cooking facilities. When you're on some of these residential properties, clearly you're going to have issues getting into what are essentially people's backyards where these buildings exist. So fire department access to these things, I would argue, for an ADU might be more challenging than for even a brand new commercial project. What's been your take on these sorts of efforts to create ADUs? ADUs that get created all across the state. So when we start getting out in the western portion of the state, sort of the response of, well, just put in a sprinkler system runs into the problems of, when you're out in the western portion of the state, there's no municipal water supply. So you're digging a second well, and now you're into fire pumps and other things of that nature, all for a 1,000, 2,000 square foot structure. So what's your thought on that? What's your take? Is it a case by case, just have to deal with it that way? Is there a larger kind of thought about how we might address the issue of getting these things built, but also dealing with the fire department requirements to make sure that they're safe and accessible in the event of an emergency?
So they will almost always will be a case by case basis. The first side of it is just meet the tolerance of that community, and there's some of the stuff we spoke to earlier. Boston and Cambridge are going to look at things a lot differently than North Adams is going to look at things. Right. We've run into situations in Boston where we've had buildings behind buildings, courtyards that only access really is to jump over the neighbor's fence to get to it. Buildings that are built to right tight to the lot lines on the left and right side, party walls with adjacent properties. How do you provide access to the backyard when on Commonwealth Ave in Boston, a great example. I've got a building that's essentially, it's one building that's a block long. Yes, it's 35 different buildings, but for all intents and purposes, it's a block long building. How do I provide the 250 foot or 150 foot number if I'm hitting it from two sides of the building? And Boston looks at that and goes, yeah, that's Com Ave. That's how it works. We get it. We're okay with it. And honestly, it's more often than not, the smaller communities that have the bigger challenges and are pushing harder on stuff. At least that's what we're seeing. With those smaller communities, I say generally you don't have as many access problems just because you can jump around the neighbor's yard. You don't necessarily need an easement for fire department access. You don't need a sign off from the neighbor say, yes, go ahead, the fire department can charge through my yard. We've done this in a number of communities that the property next door has their roadway that leads into the facility up to the property line. They use the 30 foot of road that they use for their parking lot is their 30 foot of separation between the building and the property line. So then the next door neighbor builds his building up tight to the property line. Well, we still have a 30 foot road that's there. And the fire department has looked at that and said, yeah, we'll use the neighbor's driveway. We're perfectly okay with that. If you were in someplace, and I say a small community, I have not done any fire department access stuff with Hudson, but I use Hudson as a great example of a small community with a very dense downtown. If you've driven through downtown Hudson, it's, 3-4 story buildings right up tight to each other, right up to the street. Even there, though, you can generally get on a street line and come back in. So the fire department access stuff doesn't necessarily have to be, I park my truck in one spot and I have full access. If you have to drive around the block and 2 trucks can hit it from opposite sides, that's usually okay.
Okay. Thank you.
All right, Jeremy, I have an unusual situation. I have to run to go meet with a contractor, but if you want to hang around, I don't mind making you the host and you can close the meeting.
I actually have another meeting that started 3 minutes ago that I'm supposed to be on, so it's
Perfect. So I think we're going to call it today. Everyone, thank you, Jeremy. By all means, if you have questions, please reach out to Jeremy and Code Red if you want more information.
all right. Thank you, everybody. Appreciate it.
Have a good one. Bye-bye.